The National Electrical Code, or NEC, doesn't specifically mandate a main breaker in a meter panel combination. However, it's crucial to verify local codes, as they might impose additional requirements beyond the NEC baseline. The 6 disconnect rule, as detailed in NEC section 230.71. A permits the use of multiple disconnects instead of a single main breaker. This approach is more commonly seen in commercial and industrial contexts, but it can also be applied to residential installations under certain conditions. A panel board, according to the NEC definition, is a single panel containing circuit breakers or fuses designed to distribute electrical power throughout a building. Section 408.36 of the NEC focuses on lighting and appliance branch circuit panel boards, or LABCPs. This section stipulates that an LABC must be protected by no more than 2 overcurrent devices, such as circuit breakers. The rationale behind Rule 408.36 stems from the typical application of LABCs in residential settings. These environments often feature a high density of lighting and appliance loads. The dual overcurrent device protection strategy is intended to provide adequate safety for these concentrated loads, preventing the panel board from being overloaded. Regarding a setup with 2 100-amp breakers feeding interior panels, along with 2 single-pole 20-amp breakers for outdoor receptacles and a 2-pole 30-amp breaker for an air conditioning unit, the arrangement technically adheres to the 6 disconnect rule outlined in NEC section 230.71. However, it potentially violates the stipulations of NEC section 408.36 concerning LABCPs. If the panel board functions as an LABC, distributing power to lighting and appliance loads within a dwelling, it must be protected by no more than 2 overcurrent devices. To rectify a non-compliant situation, it's recommended to remove the 2 100-amp breakers that supply the interior panels and replace them with a single main breaker rated for 200 amps. This adjustment ensures proper panel board protection and brings the installation into compliance with both NEC sections 230.71 and 408.36. In more detail, firstly, understanding the definition of a panel board is critical. The NEC defines a panel board as an assembly of devices, including buses and automatic overcurrent protection devices, designed for the control of light, heat, or power circuits. It is designed to be placed in or against a wall or partition and accessible only from the front. Secondly, it's important to differentiate between different types of panel boards. The NEC recognizes several types, including lighting and appliance branch circuit panel boards, power panel boards, and others. LABCPs are specifically designed for residential and light commercial applications where a significant portion of the load is lighting and appliances. Thirdly, the 6 disconnect rule, found in NEC section 230.71, allows a maximum of 6 switches or circuit breakers to serve as the main disconnecting means for service. This rule is often applied when a single main breaker is not practical or desired, such as in large commercial or industrial installations. Fourthly, NEC section 408.36, titled Overcurrent Protection, provides specific requirements for the overcurrent protection of panel boards. Subsection A specifically addresses lighting and appliance branch circuit panel boards, mandating that they be individually protected on the supply side by not more than 2 main circuit breakers or sets of fuses. Fifthly, the purpose of the 2 overcurrent device rule for LABCPs is to limit the potential for overloading the panel board. By restricting the number of main overcurrent devices, the NEC aims to prevent excessive current draw that could lead to overheating, damage, or even fire. Sixthly, determining whether a panel board qualifies as an LABCP is crucial for applying the correct code requirements. According to the NEC definition, a lighting and appliance branch circuit panel board is one having more than 10% of its overcurrent devices rated 30 amps or less, for which neutral connections are provided. Seventhly, when evaluating an electrical installation, it's essential to consider the specific loads being served by the panel board. If the panel board primarily supplies lighting and appliance circuits, it is more likely to be classified as an LABCP and subject to the 2 overcurrent device rule. Eighthly, in situations where a panel board does not meet the definition of an LABCP, the two overcurrent device rule does not apply. Power panel boards, for example, may have different overcurrent protection requirements based on their specific application and load characteristics. Ninthly, the ampacity of the main breaker or overcurrent devices protecting a panel board must be appropriately sized for the connected load. The NEC provides detailed calculations and guidelines for determining the correct ampacity based on the type and size of the loads being served. Tenthly, it's essential to consider the available short-circuit current at the panel board location. The overcurrent devices must have an interrupting rating sufficient to safely interrupt the maximum available fault current. 11thly, local amendments to the NEC may exist, potentially adding or modifying requirements for panel board installations. Always consult with local authorities and inspectors to ensure compliance with all applicable codes and regulations. 12thly, proper labeling of panel boards is crucial for safety and maintenance. The panel board must be clearly labeled to indicate its purpose, the circuits it serves, and the location of the main disconnecting means. 13thly, regular inspection and maintenance of panel boards are essential for ensuring continued safe and reliable operation. This includes checking for loose connections, damaged components, and proper overcurrent protection. 14thly, when modifying or upgrading an existing panel board, it's important to evaluate the entire electrical system to ensure that it can safely handle the increased load. This may involve upgrading the service entrance, conductors, or other components. 15thly, working on electrical systems can be dangerous. Always de-energize the panel board and follow proper safety procedures before performing any work. If you are not qualified to perform electrical work, consult with a licensed electrician. 16thly, the NEC is a comprehensive document, and it's essential to stay up to date with the latest edition to ensure compliance with current requirements. 17thly, understanding the substantiation behind code requirements can provide valuable insight into the intent and purpose of the rules. This can help in making informed decisions about electrical installations and ensuring safety. 18thly, the two overcurrent device rule for LABCPs is not intended to restrict the number of branch circuits that can be served by the panel board. It only limits the number of main overcurrent devices protecting the panel board as a whole. 19thly, in some cases, it may be necessary to install a separate subpanel to accommodate additional circuits or loads. This can help to avoid overloading the existing panel board and ensure proper overcurrent protection. 20thly, when selecting overcurrent devices for a panel board, it's important to consider the coordination of the devices. This involves ensuring that the overcurrent devices are sized and selected to trip in a coordinated manner, minimizing the impact of faults on the electrical system. 21st, arc fault circuit interrupters, or size and ground fault circuit interrupters, or GFCIs, are specialized overcurrent devices that provide enhanced protection against electrical hazards. The NEC requires a size and GFCIs in certain locations to protect against arc faults and ground faults, respectively. 22nd, surge protective devices, or SPDs, can be installed in panel boards to protect sensitive electronic equipment from voltage surges. SPD diverts surge current away from the protected equipment, reducing the risk of damage. 23rd, when installing a panel board, it's important to ensure that it is properly grounded and bonded. Grounding and bonding provide a low impedance path for fault current, helping to protect against electrical shock hazards. 24th, the NEC provides detailed requirements for the installation and support of panel boards. The panel board must be securely mounted and supported to prevent damage or displacement. 25th, when running conductors to a panel board, it's important to follow the NEC requirements for conductor ampacity, directing, and overcurrent protection. The conductors must be sized to carry the intended load and protected against overcurrent. 26. The NEC also provides requirements for the separation of conductors of different systems within a panel board. This helps to prevent interference and ensure the safe operation of the electrical system. 27th. When terminating conductors at a panel board, it's important to use the proper termination methods and torque specifications. Improper terminations can lead to loose connections, overheating, and electrical failures. 28th, the NEC provides requirements for the use of listed and labeled equipment. Only equipment that has been tested and listed by a recognized testing laboratory should be used in electrical installations. 29th, when working on electrical systems, it's important to be aware of the potential hazards and to take appropriate precautions. This includes wearing appropriate personal protective equipment, such as gloves and eye protection. 30th, the NEC is not a design manual, and it does not provide all of the information necessary to design a complete electrical system. It's important to consult with a qualified electrical engineer or designer for assistance with complex electrical projects. 31st, the NEC is a living document that is constantly being updated and revised to reflect changes in technology and safety practices. It's important to stay informed about the latest changes to the code and to incorporate them into your electrical work. 32nd, understanding the NEC is essential for anyone involved in the design, installation, or maintenance of electrical systems. By following the code, you can help to ensure the safety and reliability of electrical installations. 33rd, the specific requirements for panelboard installations can vary depending on the application, the size of the load, and the local codes and regulations. It's important to carefully review all applicable requirements before beginning any electrical work. 34th, when in doubt, it's always best to consult with a qualified electrical professional. They can provide expert guidance and assistance to ensure that your electrical work is safe and compliant with all applicable codes and regulations. 35th, consider consulting an electrical engineer for complex or critical electrical installations to ensure optimal safety and performance. 36th, prioritize safety above all else when working with electrical systems, and always follow established safety procedures and guidelines. 37th, continuous education and training in electrical codes and practices are crucial for staying current with industry standards and ensuring competency. 38th, use high-quality materials and equipment that meet or exceed industry standards to ensure the longevity and reliability of electrical installations. 39th, document all electrical work performed, including detailed diagrams and specifications, for future reference and maintenance purposes. 40th, regularly inspect electrical systems for signs of wear, damage, or potential hazards, and address any issues promptly to prevent future problems. The information provided is for general guidance only, and it is not a substitute for professional electrical advice. Always consult with a qualified electrician for any electrical work or projects.